Welcome to another CollectionSpy video demo. This video will explore two class-centric CollectionSpy features, the element classes and class relationships views. As a program is profiled, the element classes view lists all encountered element types and the number of times their hashcode and equals methods are called. By clicking the column headers of either method, you can sort the view on these method invocation counts. See how easy it is to determine which classes make heavy use of the often poorly implemented hashcode and equals overrides. This table also lets you see which classes do not have the hashcode or equals method called, which is often a telltale clue that something isn't right. For example, if you provided a hashcode override for a class and its count stays 0, then you are looking at a dead code scenario. The class relationships view is another view that focuses on classes, not instances. This view lets you see how various classes are related in a field-based container usage relationship. Because such relationships can be viewed from different angles, the view provides a relationship type selector. The default relationship type reflects the familiar source code hierarchy of user class, field declaration, collection type, and element type. Several other relationship types can be selected, such as relationships that use as starting point the collection type, or the element type instead of the user class. When profiling, the class relationships tree fills up with any encountered relationship information. Using the default relationship type, if we drill down in the Java AWT font text attribute class, for example, we can see that it declares one field called instance map that binds to a map container. Note that the field is declared using an interface container type. By drilling down on the field, we can see that its runtime type is actually hashmap. Further drilling tells you the key type for this map, in this case string. This is information which can only be obtained reliably through runtime analysis as provided by CollectionSpy. If we keep the text attribute class in mind and switch the relationship focus to, for example, collection element user class, we can visualize the same information, but from a completely different angle. To do so, we drill down on hashmap using string keys. And here we find the using text attribute class again. The same information can be seen from yet another perspective, in an element-centric relationships view. So let's select the element collection user class relationship permutation. Now we can see that the string class is used by lots of container types, hashmap being just one example. When we expand the hashmap class, we see that text attribute is just one of the user classes that uses hashmaps using strings as keys. Remember that the class relationships view is populated from runtime information, not static source code information. Indeed, CollectionSpy doesn't rely on any source code for profiled applications, so the shown information can be captured from programs whose source code is not even available. A typical use case for this view is reverse engineering legacy code, which could not use Java generics to declare element types for containers. Using CollectionSpy's unique class relationships view, you can quickly obtain the type information you expect and need to understand, enhance, or maintain large Java applications. The next demo video will explain other features available only in CollectionSpy, the only profiler for the Java collection framework.